Alright, if you watched the video on acceleration and velocity, I ended up giving you 3 equations. With the original velocity video, you have 4. So I'm going to write those down here to refresh your memory. I have V is equal to the change in displacement over time. I have V final is equal to V initial plus acceleration times the time. This is average velocity. A-V-E-R-A-G-E, average velocity. Okay, this is initial, this is final velocity, so these are different. This, the velocity is changing. This one, the velocity isn't changing. So I have this equation, I have this equation. I have the displacement in acceleration is equal to initial velocity times the time plus 1/2 acceleration times the time squared. And last, I have the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the change in the displacement. Those are the 4 I gave you. So now I have some sample problems. I'm going to go ahead and use these, show you the wording of the problem, and show you a specific method I need to see on a hard copy. A hard copy is the work you do on each of your UT homeworks. You don't have to copy down the question. I'm not looking for the question. I'm looking for your work. So let me give you a couple of examples. So here's a question. It says also, by the way, these sample questions are on the calendar. So if you go to the calendar, click on the assignment, there is a link where you can print off these questions and you can work them alongside, so you don't have to write the questions down. So pause the video. Why don't you do that first if you have a printer? If not, you could just follow along. So the way we do these problems is called the GUESS method. G-U-E-S-S. G-U-E-S-S. And I'll explain what each of those letters mean as we work our way through. The G is to list the given information. So this question says, a car accelerates from rest to 40 meters per second in 8 seconds. I have a 2-part question. A, what is the acceleration? And B, how far does it travel? So let me split this a little bit. So I'll do A over here and I'll do B over there. So I'm going to list the information. So, and then when you list the information, assign it the correct variable. I have an initial velocity, which is rest. That is a value. So it started at 0. VI is 0 meters per second. It has a final velocity of 40 meters per second. 40 meters per second. And I have one more, and it has a time. It has a time of 8 seconds. I have my information and I assigned it the correct variable. So that's the G. The U is the unknown. What am I looking for? I'm looking for the acceleration. I'm looking for A. So I've done the G, I've done the U. The E is the equation. I need to take the equation, rearrange it for the variable that I'm looking for. And then the question is, how do you know which equation to choose? Well, you look at what you have. Of what you have, you find the equation that has all of those variables plus the one you're looking for. So I have a VI, I have a VF, I have a T, and I'm looking for A. So it seems to me like I'm going to choose this one. VF, VI, T, and there's the A I'm looking for. So that's the equation I want, but I have to rearrange it to say A equals whatever else is in the equation. And you've had practice with that with the literal equations. That's why I had you do it. So if I rearrange this equation to solve for A, I get A is equal to VF minus VI divided by T. So that is the rearranged equation. That's the E I'm looking for. I'm looking for the rearranged equation, not the original. S stands for substitution. So now all I have to do is put in my numbers. 40 minus 0 over 8 VF. Oh, there goes the light again. So 40 is VF, VI is 0, and the time is 8 seconds. So now the only thing that's left is to solve the final S, which is 40 divided by 8. So A is 5 meters per second squared. Meters per second squared is the unit for acceleration. So that's A. B says, how far does it travel? So I have all of these variables, plus I'm looking for one more. I'm looking for delta x. How far does it travel? Well, of all of my equations, I have an initial velocity, I have a time, I have an acceleration now, and I'm looking for how far it travels. So this is the one I want to use. And luckily, it's already in the form to solve for the displacement. So I don't have to rearrange it. I just have to write it down. So delta x is equal to VIT plus 1/2 AT squared. And now we substitute in the numbers. The initial velocity is 0, and the time is 8 seconds. Same problem, same numbers, nothing's changed. Plus 1/2 times the acceleration, which I solved here, which is 5, times the time squared, which is 8 squared. And the only thing that's left is the math. So plug it into a calculator and get a number, and the unit for displacement is meters. So I'm going to leave the calculations up to you, and I'll write the unit out to the side. So whatever number you get, it would be that number and meters as the unit. So that's the first problem. Let's take a look at the second. A car is going 25 meters per second and accelerates 2.6 meters per second squared for 3 seconds. So my G, let me list my givens. I have an initial velocity of 25 meters per second. I have an acceleration of 2.6 meters per second squared. I have a time of 3 seconds. And the first one is A, what is the final velocity? What is VF? Alright, well, of my 4 equations, I would choose this one here, because I have an initial velocity, I have an acceleration, I have a time, I'm looking for final velocity. This is our baby, and I don't have to rearrange it. So I can say VF is equal to VI plus AT. VF is equal to 25 plus 2.6 times 3. And whatever answer you get, VF, and the unit for velocity is meters per second. So I will leave the calculator work up to you. There you go. B wants to know how far does it travel. Well, again, I can go ahead and use that guy. Nice and easy. So I need to use, I'm solving for delta x. I've already listed my givens once, and the problem hasn't changed, so you don't have to list your givens every time. As long as you have them listed once, and you're working on the same problem, then you're fine. So I can say delta x is equal to VIT plus 1/2 AT squared. Delta x is equal to 25 times 3 plus 0.5 times an acceleration of 2.6 times 3, and I square that. I'm substituting. So there's my givens, there's my equation, there's my substitution, and the final is my solution, and the unit for displacement is meters. So whatever answer you guys get in the calculator, there you go. And then C, find the average velocity. Well, the equation for average velocity is change in the displacement over the time it took. Well, velocity is delta x over t. So whatever you got here would go there, and then your time is 3 seconds. That goes there. Okay, and then again, velocity is meters per second. So whatever answer you get, plug it in and put it right there. So are you good? Can you see the pattern? I'm hoping you can see what we're doing. We're doing the same thing every time. We're doing this guess method. If you do that and you keep your variables straight and you follow this rhythm, the equations are really easy, the math gets simple. When you take shortcuts, then we have a couple of problems. The first problem is you're going to make a mistake and I can't find it because I can't follow your work. Or you're going to make a silly mistake because you didn't do these. So make sure you follow these steps. We got a little bit of time, so why don't we do this last one here. An engineer is to design a runway to accommodate an airplane that must gain a ground speed of 70 meters per second before it can take off. If these planes are capable of accelerating at 1.7 meters per second squared, A, how long will it take them to achieve this takeoff speed? And B, what must be the minimum length of the runway? So it looks like I have, and buried in this is information. The information is not all numeric. The information can be in words, so read carefully. So it must get to 70 meters per second. It's going to start from rest. So VI is 0. That's not in the problem. It's implied. This is applied physics. So you're going to have to think. So it's going to start from rest and it has to get to 70 meters per second. Okay? And the question is, oh, and one more, and I have an acceleration of 1.75 meters per second squared. The first one is how long does it take? What is the time? And the second part of the question, which I'll do over here, is how long must the runway be? What is the displacement? How much room does it have to travel? That's delta x. So T is equal to VF minus VI over A, which is 70 minus 0 over 1.75. That will give us our time in seconds. Boy, this light does not want to stay on. Okay, and then the last one is the displacement. So delta x is equal to VIT plus 1/2 AT squared. By the time you get done with your UT homework, you will have all these memorized. So delta x is 0 times whatever time we get here, plus 0.5 times my acceleration, 1.75, again, times whatever time we get down here. So the time would go there, and the time would go there. Do your calculations, and you, let me pull this up a little bit, should get a number, and the unit is a meter. So I hope this helps. These are some sample problems you're going to see on your UT homework. If you have any question on the process, bring them to class. Good luck.